What is tantalum capacitor? How does it function and its application? A tantalum capacitor is a type of electrolytic capacitor that uses tantalum metal as the anode. It offers high capacitance in a small size, making it widely used in applications where space is limited but high capacitance is needed. Tantalum capacitors are polarized, meaning they have a positive, anode, and negative, cathode, terminal, and must be connected correctly to function. Here's a detailed breakdown of how a tantalum capacitor functions. 1. Basic structure. Anode, positive terminal. The core of the tantalum capacitor is a piece of tantalum metal that forms the anode. This tantalum is porous, increasing the surface area and allowing for more capacitance in a small volume. Dielectric. The tantalum anode is oxidized to create a thin layer of tantalum pentoxide, Ta₂O₅, which serves as the dielectric material. This dielectric layer is extremely thin but has a high dielectric constant, enabling it to store a large amount of energy. Cathode, negative terminal. The cathode is usually made from manganese dioxide, MnO2, or a conductive polymer, both of which are applied to the surface of the dielectric. This material allows the flow of electrons when the capacitor discharges. 2. Charging process. When a voltage is applied to the capacitor, the positive terminal of the power source connects to the tantalum anode, while the negative terminal connects to the cathode. As voltage is applied, electrons accumulate at the cathode, while the tantalum anode becomes positively charged. This creates an electric field across the dielectric, tantalum pentoxide layer, storing electrical energy. The thin dielectric allows for high capacitance because the amount of energy stored depends on how much charge can be separated by the thin dielectric. 3. Discharging process. When the capacitor is needed to provide power to a circuit, the capacitor discharges. This means the electrons from the cathode move towards the positive anode, supplying current to the external circuit. The capacitor can release the stored charge quickly, providing a steady current for electronic functions. 4. Polarization. Tantalum capacitors are polarized, meaning the voltage must be applied in the correct direction. If reversed, the tantalum pentoxide layer can break down, causing the capacitor to fail, short circuit. This is different from non-polarized capacitors like ceramic capacitors, which can handle voltage in either direction. 5. Capacitance and performance. The capacitance, ability to store energy, is influenced by the surface area of the tantalum anode and the thickness of the tantalum pentoxide dielectric. Tantalum capacitors are valued for their stable and predictable behavior. They perform well over a wide range of temperatures and frequencies, making them suitable for high-performance applications. 6. Equivalent series resistance, ESR. Tantalum capacitors have a low equivalent series resistance, ESR, meaning they can quickly charge and discharge with minimal energy loss. This makes them efficient in filtering, decoupling, and power supply circuits where stable voltage levels are needed. Function summary. Energy storage. Tantalum capacitors store electrical energy in the electric field created across the tantalum pentoxide dielectric. Discharge. They release energy when the circuit needs current, smoothing out power supply variations or providing energy for quick bursts of power. High stability. They offer stable performance with minimal change over time or with temperature fluctuations, making them reliable in sensitive or high-performance applications. In summary, a tantalum capacitor functions by creating a large capacitance in a small volume using a highly efficient dielectric, tantalum pentoxide, and is commonly used in circuits that require stable, reliable energy storage. The construction of a tantalum capacitor involves several key components and processes that result in its compact size and reliable performance. Below is an outline of the construction process. 1. Tantalum anode. Material. The anode is made from tantalum, a rare metal known for its high corrosion resistance and stability. This material is chosen because it forms a high-quality oxide layer, tantalum pentoxide, when exposed to oxygen, which is crucial for the capacitor's dielectric properties. Structure. The tantalum is usually made in a porous pellet or powder form. The porous structure increases the surface area, which directly increases the capacitance for a given size. More surface area means more charge can be stored. Formation process. The tantalum powder is pressed into a compact shape and then sintered, heated, to solidify it into a hard, porous pellet. A wire is connected to the pellet to act as the anode lead. 2. Dielectric layer, tantalum pentoxide. Oxidation process. After the tantalum pellet is formed, it is subjected to an anodic oxidation process. This involves applying a voltage to the tantalum in an electrolytic bath, which causes the surface of the tantalum to react with oxygen and form a thin layer of tantalum pentoxide, Ta₂O₅. Dielectric properties. Tantalum pentoxide has excellent dielectric properties, meaning it can store a large amount of electrical energy across a thin layer. The thinner the layer, the higher the capacitance, but it still needs to be strong enough to prevent breakdown under voltage. Uniform layer. The oxidation process ensures that the dielectric layer is uniform across the entire surface of the tantalum anode, which is critical for the capacitor's reliability and performance. 3. Cathode. Manganese dioxide, MnO2. The cathode is typically made from manganese dioxide, a conductive material that is applied to the surface of the dielectric. This is done through a chemical deposition process where manganese salts are converted into manganese dioxide, forming a layer on top of the dielectric. Polymer cathode, alternative in some modern tantalum capacitors. A conductive polymer replaces manganese dioxide. Polymer cathodes offer even lower equivalent series resistance, ESR, resulting in faster charge and discharge cycles and better performance at high frequencies. 4. Additional layers. Carbon layer. On top of the manganese dioxide or polymer layer, a thin layer of carbon is applied. This acts as an intermediate conductor between the cathode material and the external termination, lead. Silver layer. To further improve conductivity, a layer of silver paste is applied over the carbon layer. This silver layer connects the capacitor to the external leads. 5. Encapsulation. The tantalum capacitor is then encapsulated in a resin or plastic case to protect it from environmental factors like moisture and physical damage. This helps ensure long-term reliability, especially in harsh environments. Marking and leads. After encapsulation, the capacitor is marked with its value, capacitance, voltage rating, and leads are attached to the anode and cathode for connection to a circuit. Summary of construction layers. Tantalum anode, the core structure, providing a high surface area for charge storage. Dielectric, tantalum pentoxide, a thin, high-quality layer for storing charge. Cathode, manganese dioxide or polymer, a conductive layer that allows the capacitor to discharge stored energy. Carbon and silver layers, intermediate layers that improve conductivity and connect to external terminals. Encapsulation, protective covering that shields the internal components from damage and environmental stress. Construction diagram, simplify. Anode, tantalum pellet, porous, connected to a lead. Dielectric, tantalum pentoxide layer formed on the surface of the tantalum anode. Cathode, manganese dioxide or polymer layer covering the dielectric. Carbon and silver layers improve electrical conductivity and connect the cathode to the external circuit. Encapsulation, protective casing around the capacitor. This careful construction process is what allows tantalum capacitors to provide high capacitance in a small package while maintaining reliability and stability in various applications. Capacitance is a measure of a capacitor's ability to store electrical charge. In the case of a tantalum capacitor, the capacitance is determined by 3 primary factors. Surface area of the anode. The larger the surface area of the tantalum anode, the greater the amount of electric charge that can be stored. In tantalum capacitors, the anode is made porous to maximize its surface area, allowing for a higher capacitance in a smaller volume. Dielectric constant of tantalum pentoxide. The dielectric material used in tantalum capacitors is tantalum pentoxide, Ta₂O₅. This material has a high dielectric constant, meaning it can store more electric field energy compared to other materials, such as air or ceramic. The high dielectric constant of tantalum pentoxide contributes significantly to the high capacitance of the capacitor. Thickness of the dielectric layer. The thinner the dielectric layer, the higher the capacitance. In a tantalum capacitor, the dielectric layer is extremely thin due to the oxidation of the tantalum anode into tantalum pentoxide. This allows for high capacitance without significantly increasing the size of the capacitor. Characteristics of capacitance in tantalum capacitors. High capacitance to volume ratio. Tantalum capacitors can store a lot of charge in a small physical size, making them ideal for compact electronic devices. Stable capacitance over time. The capacitance of tantalum capacitors remains relatively constant over a wide range of temperatures and operating conditions. This stability is crucial for reliable performance in sensitive circuits. Low leakage current. Tantalum capacitors generally exhibit low leakage current, meaning that the stored charge does not dissipate quickly over time. This makes them suitable for applications where long-term energy storage is important. Practical capacitance values. Tantalum capacitors typically have capacitance values ranging from 0.1 F to 1000 F or more, depending on their size and construction. They are often used in circuits where high capacitance is needed but where physical space is limited, such as in power supply filtering, decoupling, and timing circuits. Summary. The capacitance of a tantalum capacitor is a function of the anode surface area, the dielectric constant of tantalum pentoxide, and the thickness of the dielectric layer. Tantalum capacitors are valued for their ability to provide high capacitance in a small volume, with stable, reliable performance across various applications. The functionality of a tantalum capacitor involves its ability to store and release electrical energy in an electronic circuit. Here's how it operates and contributes to circuit performance. 1. Energy storage. A tantalum capacitor stores energy in the form of an electric field. When a voltage is applied across its terminals, positive and negative charges accumulate on the anode and cathode, respectively. The thin dielectric layer of tantalum pentoxide between the anode, tantalum, and cathode, manganese dioxide or polymer, prevents direct electrical flow, allowing charge separation and energy storage. 2. Polarized capacitor. Polarization means that the capacitor has specific positive and negative terminals, anode and cathode. It must be connected with the correct polarity in the circuit. If the polarity is reversed, the capacitor can break down, leading to failure or even a short circuit. This is because the dielectric layer, tantalum pentoxide, is designed to handle electric fields in one direction. 3. Charging process. When voltage is applied, the tantalum capacitor charges by accumulating electric charge at the anode and cathode. The electric field is established across the dielectric. The capacitor continues to charge until the voltage across its terminals matches the applied voltage. 4. Discharging process. When the circuit requires energy, the capacitor discharges by releasing the stored electrical energy back into the circuit. The stored charge flows from the cathode to the anode, providing current to the circuit. The discharge happens when the external circuit demands more current than the power supply can instantly provide, or when the circuit is briefly powered off. 5. Equivalent series resistance, ESR. Tantalum capacitors have a low equivalent series resistance, ESR, meaning they can quickly respond to changes in voltage or current demand in the circuit. This makes them ideal for decoupling, reducing noise and voltage spikes, and filtering applications, where fast charge/discharge cycles are essential for stabilizing voltage supplies. 6. Capacitive reactance, AC functionality. In AC, alternating current, circuits, capacitors impede the flow of current at different frequencies. Tantalum capacitors, like other capacitors, offer high impedance at low frequencies and low impedance at high frequencies. This makes them suitable for filtering out noise, high-frequency signals, from power supplies and signal lines, as they effectively block DC, direct current, while allowing AC signals to pass. 7. Voltage regulation and smoothing. Tantalum capacitors are commonly used for voltage smoothing in power supply circuits. They help maintain a steady voltage level by storing energy during voltage peaks and releasing it during voltage drops. In switching power supplies, they filter out voltage ripples, ensuring that the output voltage remains stable. 8. Timing circuits. In RC, resistor capacitor, timing circuits, tantalum capacitors are used to control the charging and discharging time, which helps in creating time delays or setting oscillation frequencies in clocks, timers, or pulse circuits. The charging and discharging of the capacitor determine how long it takes for the voltage to reach a certain level, thus determining the timing interval. 9. Filtering. Decoupling capacitors. Tantalum capacitors are often placed across power supply lines near integrated circuits, ICs, to remove noise and stabilize the voltage. This process is called decoupling. They help smooth out power variations and suppress noise from other components in the circuit. Signal filtering. In signal processing, capacitors are used in low-pass filters to block high-frequency signals, allowing only the desired lower frequencies to pass. Tantalum capacitors, with their high capacitance, are particularly effective in this role. 10. Stable capacitance. Tantalum capacitors exhibit stable performance over a wide range of temperatures, making them reliable for use in high-temperature and high-stress environments, such as automotive or aerospace applications. The capacitance remains relatively constant over time, with minimal drift or loss of performance, ensuring long-term reliability. Summary of functionality. Stores energy. Tantalum capacitors accumulate electric charge and release it when needed. Polarized. Must be connected with the correct polarity in a circuit. Charges/discharges. Charges when voltage is applied and discharges when the circuit demands current. Voltage smoothing. Helps stabilize voltage by filtering out fluctuations. Low ESR. Quickly responds to changes in current demand and reduces energy loss. AC filtering. Blocks low-frequency noise and allows desired signals to pass. Timing applications. Used in RC circuits to control time intervals. The primary role of a tantalum capacitor in an electronic circuit is to provide reliable energy storage and release, smooth out voltage variations, filter signals, and maintain stability in the presence of electrical noise or spikes. Tantalum capacitors are widely used in various industries due to their reliability, small size, and high capacitance. Below are some key applications where tantalum capacitors play a critical role. 1. Consumer electronics. Mobile phones. Tantalum capacitors are used in smartphones for power management, ensuring smooth power delivery to components like processors and memory chips. Their small size and high capacitance make them ideal for compact devices. Laptops and tablets. In laptops and tablets, they are used for decoupling and power filtering, helping stabilize voltage for the processors, graphics cards, and memory. Wearable devices. Due to their small size and high stability, they are used in fitness trackers, smartwatches, and other wearable devices where space is limited. 2. Automotive electronics. Advanced driver assistance systems, ADAS, tantalum capacitors are used in safety-critical systems like ADAS, which include sensors, cameras, radar, and control systems. These systems require reliable capacitors that can handle fluctuations in power supply. Infotainment systems. Modern cars are equipped with entertainment systems, touchscreens, and GPS units. Tantalum capacitors help ensure stable power delivery, preventing flickering or interruptions. Powertrain and control modules. In electric vehicles, EVs, and hybrid vehicles, tantalum capacitors are used in powertrain control units and other control systems for stability in fluctuating voltage environments. 3. Medical devices. Pacemakers. In life-critical applications such as pacemakers and defibrillators, tantalum capacitors are used because of their long life, reliability, and stable performance. They help manage the small power requirements for these devices. Portable medical equipment. Devices like insulin pumps, hearing aids, and diagnostic machines use tantalum capacitors to ensure consistent power delivery in compact designs. Imaging systems. Medical imaging systems like MRI and CT scanners use tantalum capacitors for signal filtering and power regulation in sensitive, high-precision environments. 4. Aerospace and defense. Military communication systems. Tantalum capacitors are widely used in military radios, communication devices, and encryption systems due to their durability and resistance to harsh environments. Radar and navigation systems. In aerospace applications, tantalum capacitors are critical for radar and navigation systems where long-term reliability and resistance to extreme temperatures are required. Guided missile systems. Tantalum capacitors are often found in guidance systems for missiles, ensuring stable power to control systems in high-stress conditions. 5. Industrial electronics. Power supply units. Tantalum capacitors are commonly used in industrial power supplies to filter out voltage noise and provide stable output, ensuring the smooth operation of sensitive equipment. Automation systems. They are used in industrial automation systems for controlling motors, sensors, and actuators, ensuring that the system operates smoothly with stable power. Energy storage systems. In energy storage applications, tantalum capacitors are used to smooth out voltage fluctuations, and provide short-term energy storage. 6. Computers and networking. Motherboards. Tantalum capacitors are found on motherboards to provide decoupling and filtering for processors, memory, and power supplies. They stabilize power delivery and reduce noise. Routers and switches. Networking devices like routers and switches use tantalum capacitors for maintaining stable voltage in communication circuits and ensuring smooth data transmission. Hard drives and solid-state drives, SSDs, tantalum capacitors are used in data storage devices like SSDs to ensure that the power supply is stable and to protect data integrity in case of sudden power loss. 7. Telecommunication equipment. Base stations. In cellular base stations and telecommunications infrastructure, tantalum capacitors are used for filtering and stabilizing power in signal processing and data transmission units. 5G infrastructure. With the rollout of 5G networks, tantalum capacitors are increasingly used to ensure stable operation in compact and high-frequency systems. Satellite communication. Tantalum capacitors are used in satellite communication equipment for stable signal transmission, especially in power-sensitive applications. 8. Power management. DC-DC converters. Tantalum capacitors are used in DC-DC converters to filter voltage and smooth out ripple currents, ensuring consistent output voltage. This is important in applications where voltage stability is critical, such as in portable electronics and battery-operated devices. Voltage regulation. They help in voltage regulation circuits by smoothing out fluctuations and reducing noise, which improves the reliability of sensitive electronic components. 9. Audio equipment. Amplifiers and audio systems. In high-end audio systems, tantalum capacitors are used for filtering and power regulation, which ensures smooth sound quality by reducing noise and distortion. Signal filtering. They are used in the signal path to filter out unwanted frequencies and noise, ensuring high-quality audio output. 10. Other specialized applications. Space exploration. Tantalum capacitors are used in spacecraft for their stability, reliability, and ability to function in extreme conditions, such as temperature fluctuations and radiation. Renewable energy. In solar power systems and wind turbines, tantalum capacitors are used for power conditioning, helping to stabilize and filter the energy generated from these sources before it's delivered to the grid or stored. Summary. Tantalum capacitors are integral to applications where high capacitance, small size, and reliability are required. Their main applications include consumer electronics, automotive systems, medical devices, aerospace and defense, industrial electronics, and more. They ensure stable power supply, filter noise, and smooth voltage fluctuations in critical circuits across these sectors. Tantalum capacitors offer several advantages over other types of capacitors, such as electrolytic and ceramic capacitors. Here's a breakdown of the key advantages of tantalum capacitors. 1. High capacitance to volume ratio. Compact size. Tantalum capacitors provide high capacitance in a small package, making them ideal for space-constrained applications like mobile phones, laptops, and wearable devices. Efficient use of space. The porous structure of the tantalum anode increases the surface area, allowing for more charge storage in a smaller volume compared to other capacitors. 2. Long-term stability and reliability. Stable capacitance. Tantalum capacitors maintain their capacitance values consistently over time, with minimal drift or degradation. This makes them highly reliable in applications where stable performance is critical. Low leakage current. They have low leakage current, meaning they retain their charge well over extended periods. This is beneficial in battery-powered devices, where energy efficiency is essential. Durability. Tantalum capacitors are known for their robustness, especially in high-stress or harsh environments, including high-temperature and high-humidity conditions. 3. Wide temperature range. Performance in extreme conditions. Tantalum capacitors can operate effectively over a wide temperature range, typically from -55 degrees Celsius to +125 degrees Celsius, making them suitable for automotive, aerospace, and military applications where environmental conditions are challenging. Consistent performance. Their capacitance and electrical characteristics remain relatively stable across varying temperatures, ensuring reliable performance in critical applications. 4. Low equivalent series resistance, ESR. Efficient energy transfer. Tantalum capacitors have a low ESR, which allows them to respond quickly to changes in voltage and current. This makes them well suited for high-frequency applications like power supply filtering and decoupling. Low heat generation. Due to their low ESR, tantalum capacitors dissipate less energy as heat, improving energy efficiency and extending the life of components in power-critical systems. 5. Excellent filtering and decoupling capabilities. Voltage smoothing. Tantalum capacitors are effective at filtering out noise and smoothing voltage fluctuations, especially in power supply circuits. They ensure stable power delivery to sensitive components like microprocessors and memory chips. Effective at high frequencies. Their low ESR and good frequency characteristics allow them to perform well in high-frequency filtering applications, such as RF circuits and switch-mode power supplies, SMPS. 6. Polarized, low-impedance performance. Reliable in polarized circuits. Tantalum capacitors are polarized, meaning they have distinct positive and negative terminals, which are advantageous in DC circuits where consistent charge storage and release are required. Low impedance. They exhibit low impedance across a wide range of frequencies, ensuring efficient signal filtering and power delivery in many applications. 7. Superior frequency characteristics. Minimal signal distortion. Tantalum capacitors exhibit better frequency characteristics than aluminum electrolytic capacitors, making them ideal for applications requiring minimal distortion, such as in audio systems and signal processing circuits. Good high-frequency performance. Their construction allows them to handle high-frequency signals more effectively than some other types of capacitors, making them useful in RF, radio frequency, applications. 8. Low equivalent series inductance, ESL. Improved high-speed performance. Tantalum capacitors have a low ESL, meaning they perform better in circuits that require fast charge and discharge cycles, such as in high-speed digital circuits. 9. Resistance to drying out. Unlike aluminum electrolytic capacitors, tantalum capacitors do not use a liquid electrolyte that can evaporate or dry out over time. This makes them more reliable and longer-lasting, particularly in high-temperature environments. 10. High reliability in critical applications. Medical devices and aerospace. Tantalum capacitors are often used in critical applications, such as medical implants, e.g., pacemakers, and aerospace systems, because of their proven reliability and performance over time. Shock and vibration resistance. They are also known for their robustness against mechanical shock and vibration, which is crucial in applications like automotive and military equipment. 11. Better tolerance to reverse voltages with polymer types. Polymer tantalum capacitors. Newer tantalum capacitors that use polymer cathodes instead of manganese dioxide have better tolerance to reverse voltage conditions and can recover from such events more effectively without catastrophic failure. Summary of advantages. High capacitance in a small size. Ideal for compact designs. Stable and reliable. Long-term stability with low leakage current. Wide temperature range. Performs well in extreme temperatures. Low ESR. Efficient energy transfer with low heat generation. Excellent filtering. Great for voltage smoothing and high-frequency filtering. Low impedance and ESL. Suitable for high-speed and high-frequency applications. Durable and long-lasting. Resistant to drying out and mechanical stress. Reliable in critical applications. Used in medical devices, aerospace, and automotive electronics. These advantages make tantalum capacitors highly suitable for demanding applications requiring high reliability, space efficiency, and stable performance over time. However, they are sensitive to reverse polarity and high voltage, which can lead to failure, short circuit, if not handled correctly.